So, welcome to our PhD Forum event as part of the enrichment activities for MSc Big Data students and also for mathematics students. Our guests today are some of our PhD students from the Data Science Research Center, Laura Erhan and Francis Malute, so they will present. We also have Lucia Cavallaro and also Marilyn Duboacu. They will also have separate sessions later on. And we also have some guests from the MSc Big Data Analytics. So I would like now to invite Francis to briefly overview his PhD topic. So Francis, you could tell us a few things about your PhD project, what it's like to be a PhD student and also employed, and you know, some of the lessons you've learned, some of the challenges you have to overcome. So this will be maybe like 10-15 minutes.
Yeah. Thank you very much. Yes, my name is Francis Malute. I am doing my third and final year. I have just recently finished my second year. My area of research is machine learning approaches that can be used to augment security in cloud-assisted Internet of Things. I think at this stage, what I'm going to do is just to share a presentation. I will not be going through slide by slide. I will just be going to those important issues, you know, to this forum. So I hope it will allow me to share. My supervisors there, my supervisors on that one, Dr. King, Ovidiu, and I have an external supervisor there who is basically maybe the project founder, Professor Antonio, who is now based in Italy. Okay, and my area of research is looking into machine learning approaches that can be used in edge computing, particularly to enhance or to augment security, where the storage of data will be based on cloud assisted. And the motivation, I was motivated by this quote there, which says that in any field, find the strangest thing and then exploit. Now, IoT was not there in the yester years, that is maybe pre-1980s, etc., etc. It was a concept that was coined by Ashton in 1999, where he used his RFIDs to track goods in the supply chain. As such, because it was just used for tracking purposes, security was not a consideration. And hence the development, the manufacture of these IoT devices, they are going on without due consideration to security. Right. So as a result, you realize that a lot of data is being produced. And if we are to check in the news right now, on these slides, as you can see, we have got smart home security, which is the third point, which is being projected to grow by 40% by 2023. And this is just an article that has been released about 21 hours ago. Again, in the UK, there is an outcry in terms of data sharing as the England's NHS plans to share their patient records with third parties. So we have got about 55 million patient records that are going to be shared by, you know, unknown third parties. And the issue here of data confidentiality, integrity, and privacy, which is what we call our CIA, comes into question. And this is about 4 hours ago. And as a reaction to these two last points, the first point now is simply saying the UK, again, they have introduced consumer IoT cybersecurity legislation, and this is from Global Data Technology from the 27th of April, to make sure that the manufacturers, the distributors, and the consumers of IoT generated data are abiding by specific ethical requirements so that security or information can be shared securely. Okay, so this is to add on to the motivation of my research, which I started long back, about 2 or so years ago. Just sorry there, I'm on slide. Can you confirm, please? Can you see the same slide as me? Can you see slide 8?
Yes, I do.
Yeah, I can see this one with what we know from research so far.
Exactly. Yeah.
Yes. So can you see the other one now? Now, which one can you see? Is it contextualization?
No, it's
What
the same.
we know from research so far.
Yeah, still the previous one.
Okay. All right. So this one is about what have we known from research now as far as that IoT is concerned, especially in home automation. What we have seen there is that the IoT devices that are being used in homes, they come preloaded with keys. They come with a lot of manufacturer defaults that can create loopholes that can be exploited by hackers or third parties who want to collect data for their own reasons and their own purposes. So as a result, we have had some security approaches that have put in place to make sure that is mitigated. So you realize that we have got different companies, in other words, different organizations coming up with different approaches here, others coming up with different layers, others proposing that in order for us to mitigate, to strengthen, to make sure that information is secured, we need to implement a 3-layer approach that will detect information maybe from the network layer, the communication layer, and the application layer. Others are coming up with 4 layers. Some others are also coming with 5 layers. Whilst, Cisco, for example, they are coming up with 7 layers. Okay, so this difference in layers also means that security will be treated differently by manufacturers, by the software developers, and the users, with the consumers who are going to purchase these devices, who are going to download these applications, might be, blind to all these things, and yet we will purchase those and use them in our day-to-day lives. All right. So as you can see there, we also have got different protocols. So because you've got different players, they are inclined to different security protocols that they use to safeguard their data. So as you can see here, we do have got different approaches, to different technologies that might introduce a lot of loopholes that can be exploited, especially to those devices that we might be finding in our homes, devices that we'll be using to lock our doors, devices that we'll be using, for example, in our fridges, in our stoves, in our home, entertainment systems, etc., etc. So coming up with a security solution to that becomes a challenge. So furthermore, other researchers now have looked into data security in terms of, as you can see, those 4 layers, which is what I have adopted there on the edge, and the application layer there and the middle layer. These are my areas of research. I have made assumption that the perception layer, where you've got all these sensing devices, physical security, to be honest. There are already some solutions in place there, and it's an area that is hardware dependent. I'm trying to concentrate more on the software, and the software sections, they start from the middleware layer and the application layer. The network layer here, that's where you've got all the communication technologies, and there are quite a lot of protection measures that are already in place. Now, faced with all this situation where we have got different approaches to layers, we've got different protocols, we've got different applications that are being generated by different companies, I realized that there must be a need to have solution, computing solution or IoT security here that will definitely focus on data security. So the core value here is to look into data security and say, okay, first with all these, in terms of these Venn diagrams, first with all these attack surfaces, what is it that we can do in terms of data security? Okay, there are already some solutions that are there that are proposed, but my solution, which I am going to propose here, will try to look into those protection measures to make sure that security in the nodes that can communicate directly to the cloud there, and those that can do machine to machine, or what we call node to node, without passing through the gateway, will be enforced to make sure that any communication that leaves the home environment will have to go through the home gateway with that particular mechanism. So that resulted in a situation whereby I ended up now proposing this solution here, as you can see, and the justification being here that we cannot rely on the non-dynamic methods for IoT edge security in home automation. So that's where the machine learning aspect comes in, whereby we can be able to detect some specific behavioral attributes of how the systems that we are already in place using, semi-supervised methods. Yeah, basically that's that, and those are the research objectives, which I, for the purpose of time, I might not be able to go through that. In terms of methodology, I'm using simulation. I've done some packet tracer. So this is work in progress now. This is where the most focus is happening. I wanted to use a test bed, but due to the challenges, COVID-related challenges, I ended up using simulation software. Obviously, this simulation software, they are coming up with challenges. Packet tracer on its own, it's all right to track the packets moving from point A to point B, as you can see there. But the weakness is packet tracer is not a security specific software. So you need to combine it with things like Wireshark to be able to analyze that. So basically, that's where my work is at the moment. I mean, cognizant of time. The results of my research, as I can see in terms of dissemination, they will definitely help the designers, the developers, the manufacturers, academic community, as well as the IT consumers. So that's the focus of that. I am not saying I'm going to be providing a bulletproof solution, but I think if I use machine learning on the edge, focusing on the gateway, I should be able to design a lightweight system that can identify, trigger, and share some important information that result in augmenting or enhancing security in this cloud assisted framework. Again, the provision of cloud, we've got different cloud providers there as well. They all come up with their different security issues. So yes, that's really interesting in terms of that. How do we secure the information that is in transit to and in transit from the cloud at the gateway? And again, how do we secure that information that could be coming in or generated by sensors as well, passing through the gateways? So that's basically what I am looking for as work in progress. Thank you very much for that.
Yeah, thank you very much, Francis. A very interesting talk with lots of potential applications. Thank you very much. Now, Laura, if you would like to describe your project.
Yes, my presentation is slightly on a different note,
Yeah, it's fine.
more general, but I'll try sharing also.
The first slide looks very good.
Great. Yeah, so my name is Laura Erhan. I'm also a PhD student. I'm actually into my 4th year now. Let's say that doing a PhD comes with challenges in terms of time management. Somebody was telling me that probably I'm just postponing it because I don't know yet what I want to do further, you know, so I sabotage myself unconsciously. But yeah, so kind of my PhD topic lies at the intersection of the Internet of Things and edge computing. So my presentation is more around trying to explain sort of these terms. So okay. So Internet of Things, well, most of us are familiar with it. I would guess also Kaysar is. So in the end, the Internet of Things is just representing this huge network, if you want to say so, where like we have all these devices collecting data and transmitting data. So it's a very important data source and also a very important generator for the big data that we analyze nowadays. So objects that can be part of the Internet of Things can be of any kind, phones, cameras, your fridge, pretty much anything that is connected to the Internet and then collects and transmits data over it. What we look at is how the computation pipeline looks like. So there is, we have the classic cloud computing where we can do most of very heavy processing, most advanced processing. And we can see here, like in the image, that we have this huge data servers, data centers, so very powerful resources. Then we have the edge, which is where our data is, sensed and collected. Yeah, so this is where our devices, part of the Internet of Things, are placed. And then we also have something in between, which sometimes exists, sometimes it doesn't, which are like these intermediate processing units. Yeah, so here I selected a laptop, you know, because you could have your devices collecting data, sending it further to the laptop, doing some further processing, and then sending it up to the cloud. So kind of each of them has various degrees of resources for computation, and also like it incurs certain advantages and disadvantages to the whole process. So I found this image, which I think does it quite nicely. So we have the clouds, data centers, which are a few just because they are very powerful. However, they're far away, so there's latency induced when we send data and we want to get results from there. Then we have the fogs, which are more numerous than the cloud, but obviously less than the devices, which are at the edge. And they have, let's say, intermediate power, intermediate resources, which allows us to do computation. And it links the cloud and the edge. So the fog can be placed closer to the cloud or closer to the edge, depending on the setup of the system that we're talking about. And then we have the edge, where like billions of devices all generating data, collecting data. They are close to the data source, and they have limited computational resources. However, with the advancement of technology, like even these devices now do have computational power. They can do certain processing on them. So kind of what edge computing is hinting at, and what my research is looking at, the research that I'm doing is looking at, is how we can do more at the edge, how we can push part of the processing that we normally do at higher levels, how we can push it closer to the data. And it's all in the context of the Internet of Things, because the Internet of Things connects all these three layers together, because you have the devices, you have the processing. The processing for loads of the Internet of Things projects happens in the cloud. All this more advanced machine learning, deep learning, which is using the data coming from the devices, is happening in the cloud. So kind of the Internet of Things finds itself within all these three layers. So my work is pretty much about taking advantage of the edge. So why would we want to do this? First of all, because we would have less communication costs. We don't need to send all the data all the way up. We can only send the relevant information. So therefore, we just filter out the junk, because a lot of the data that we generate is just garbage, you could say. I mean, there are different reasons for that happening, but this is a different story. And also, it's low latency, because the edge is close to the data source. There's not really much traveling involved for the data. And how we can do this? We just take advantage of the resources that we have at the edge. So for example, a Raspberry Pi, a phone, all these now have like memory, they have powerful processors, so they can do some processing. Obviously, we won't run the very heavy deep learning process that we would need to run on the cloud, but we can outsource, if you want to say so. We can push some of the processes down. So for example, we can do a lot of the pre-processing, of the filtering. We can do it at the edge. So kind of we just, as we have this bunch of processing that needs to be done, we can just take a chunk of it and just push it at the edge and then do the rest up. And then we're going to have all this cost savings, also probably energy savings, and so on. So this is more of a general thing. So I'm just looking at this, how taking advantage of the edge could help, how we could perform like data imputation or anomaly detection at the edge with limited resources. Obviously not the very, very limited one, but something in between, like the Raspberry Pis. And nowadays loads of devices have way more powerful. They're not simple sensors anymore. Normally the sensors are connected to these devices which already have this more powerful resources compared to in the past. And yes, if there are questions, I'm glad to answer. And also, like, I put in my email address in case somebody is interested or gets a question afterwards and wants to send an email.
Laura, thank you very much. I think this was an excellent focused presentation of edge computing and connection to IoT, and also a very good motivation for how improvements in processing on the edge can actually help can improve the efficiency of the whole pipeline.